So now I decide to come back to the outside so I can show you. This is very much how these houses look like. They're very narrow. There's another one right here. Very nice houses. Very high quality finish. They got bricks and hardy plank. There is a chapter actually on wall covering that talks about hardy planks and soffits, right? About the nailing part, and also the bricks, about tightening the bricks to the walls, and the whip holes, which is the little holes that come out of the brick to take moisture out. But this is the finished product. You can see another one here. Very nice. You know, you use a hardy plank siding and use the technique called board and battering, which is it's actually a cement board that has cleats, the 1x3 cleats or 1x2 cleats that creates the lines that you see there. Kind of like a traditional look with handrails and all of that. You know, the handrail heights, how to attach the handrails, the space between the balusters and all of that, but it incorporates different type of materials that they are basically described and approved by the building code. Also, I don't know, you can see it, maybe I can zoom in a little bit. You can see this soffit, right? This soffit is right here. You know, it has perforated soffit, hardy product for providing ventilation to the attic, so that way moisture can escape out of. Same soffit, right? Soffits, perforated soffit. Some of the techniques will use vents or continuous vents. In this case, the material already comes with the perforations, so you don't have to use vents. See, and this is the house that I was talking about a moment ago, and this house has already what we call a house wrap, which is being taped. You can see there's been tape on every joint and all of that. This is explained on your chapter that talks about wall covering between the framing, the sheathing. Then you need to have another barrier designed for moisture, called moisture barrier or water barrier, or also drain plane. It gets different names. That is accomplished by using different type of materials. There is a sheathing plywood that comes already green or with the moisture barrier applied to the OSB plywood, also called zip system. They are not using that here. They're using another technique where you sheet with OSB plywood. Let me move to the side here. See, that's the cantilever part that you saw a while back, where it was blocked between the joists when they come out. It's mandatory. See the house? Really nice house. 3-story house using the attic too. But this is what I meant. You know, this is a house with full sheeting, right? That means this is the first video that I shoot. Plywood all the way around, which is controlling your shearing. They're not using combined techniques like they're described on your book. They're using the common technique that most people are using these days, which is just plywood the whole building and forget about it because everything is very much braced. The part that is quite confusing about bracing is because you can combine plywood, or in this case a structure plywood, or also called OSB, on certain points and then change a different material. In this case, they're using OSB plywood. So when you do something like this, then basically you pass inspection, because you're not really dedicating what they call wall lines, wall sheeting for bracing. You know, what is a wall line? It's just the entire length of the wall, right? They allow you to do offsets like you see here of 4 feet and 8 feet for diagonal sections. There is no diagonal in this case, but you can see there are some offsets, but they are no more than 4 feet. So from corner to corner, or from this corner to the other corner, that's called a wall line, right? There are some offset, but like I said, there are no 4 feet or more. So it's considered from here to here when you have to come out with how many feet you need to brace at least to provide full control of the racking movement of the wall. That technique is called bracing, right? So we have many charts in the book that talks about based on the technique that you will be using. Bracing is also the combination between the sheathing on the outside, which is what you see, with the drywall on the inside. That's why when you install these plywoods, they're supposed to install with enough fasteners or nails in the right size of nail. Is very important to control this side movement, as well as the drywall on the inside. And that technique, which in residential is perpendicular to the studs, with the right amount of screws, right size and right space. So that's basically that technique that is described. But because it has many ways to do it, and of course it's gonna be basically affected by the wind that we have, because that's the wind that is going to try to move the house, and also the earth movement. There are multiple charts based on the speed. But remember, the speed for the wind, like in our area, is 115 miles per hour to 120. You can check that back in chapter 3 when you have all the maps where Georgia is located. In this case, this is the house located in Georgia, right? So this is sheathing, right? So what's the purpose of sheathing again? To prevent that rack movement and creating shear walls, or also brace the walls, right? All those braces that you see there, those are temporary bracing. Those are not permanent bracing. There is a technique called leading brace, where the brace is actually insert into the wall by using a metal or a 1x4, at least 4 to 6 feet, 16 of center. But very few people practice that because you have to notch the lumber. It was practiced on the 70s a lot, also on the 1600, 17, 1800 in Europe. But now with the low cost of OSB plywood and this sheathing, then most people do a continuous sheathing or brace the entire wall. So that way they make sure that the house is braced correctly. What will happen if the house is not well braced? Then the house will wreck too much with the air movement or with the wind blowing, and then it will start turning and becoming off square, and eventually in one point collapse. It will take a little time to collapse, but basically will create many changes to the building. So that's the reason why inspectors will check on that. You know, they will look at the space of your nails and all of that and say, okay, you know, we passed the bracing inspection, which is part of the framing inspection. So this is a house that it was completely plywood or sheathing, and they moved to the next step, because you can do that. The first part of the building process, as soon as you frame, you want to put the roof. You see the roof is installed, the roof shingles. Why? Because we want to dry the building. We don't want the water to penetrate through the roof, through the seams, and also swell the plywood. And so that's called drying, which is basically there's a ridge vent on the top. So it's being dry by using the shingles. And then at the same time, you dry the outside and also move to the next stage. You don't have to wait, you know, because people is doing mechanical while people is working outside. If you have a good crew of framers, you can do that. And then what they're doing is putting, they install really nice, in this case, house wrap. House wrap is being a staple into the wall. You just cannot see the staple because they're tiny staples. And also they have some, when you're gonna leave the house for quite some time, this house wrap does two things. It creates a drainage plane for moisture and water. Okay, not all the house wrap are impermeable. Most of them, especially in our state, very important, the weather barrier is supposed to be placed on the outside of the wall. Okay, so there are some states up north. You can check on your energy chapter where it talks about different climate zones. Our climate zone, the rule for the building code is that the moisture barrier should be placed on the warmer side of the wall, which the warmer side for us, based on where we are, is the outside, not the inside. So that's why the barrier is on the outside. And I can say you can use house wrap, you can use felt papers, or you can actually, there's a sheeting available called SIP. It's green on the outside, which it comes already with the moisture barrier, but also it's served for wind penetrations. So that's the reason why it's taped in all the seams, so air also is prevent from coming through it. Now, even all that, because we basically don't do much drain plane, all the siding will create a lot of penetrations, so eventually lose some of the wind force property, but it does. It's house wrap, right? So as you can see, it's been a staple, but the house is going to be very much up like this for quite some time. So what happened is that the staple will start failing with the wind. So I don't know, I'm going to get a little bit closer. You can see when the house is going to stay up for a moment, you can use simplets or tabs with plastic caps to basically control. If you don't do that, then the house wrap will basically blow off. So it has simplex or these nails that has a plastic ring around it, right? You can see here the staple makes sure that, and I don't know, you can see it, but I'll see. Now I can see it. You see it has tiny perforations, right? Tiny perforations, because this house wrap, and that's because of the type of environment that we live here in Georgia. House wrap is smart, prevent water and wind from penetrating, but it has tiny perforations, so any moisture that passes through it, then that moisture can escape out. It can escape out, okay? So it's not trapped on the wall. If that is trapped on the wall, then the moisture, especially the moisture, will find a dew point and condensate inside your walls. And if they do that, then mold will start growing in your house. Okay? So we don't want that, and that's the reason why we have a perforated or house wrap, right? So it's permeable. It's a permeable house wrap. It's not impermeable. So here in Georgia, we cannot use solid permeable materials on the outside. They have to have a ratio of permeability. So they will stop the moisture and water from penetrate, but also will allow moisture to get out if it passed through some of the joints. As you can see, it will pass through it because they did it 100% perfect, because you see the bottom is open. There's another technique where you can really seal everything, but it's okay. So house wrap, I see it has tape on all the seams. House wrap is also inspected before you close it and make it like one of these. So again, the whole system is described right there. Wall system with sheathing, correctly built and all of that. Then you move into your weather barrier, which you can have multiple applications. The reason why the chapter is so long, because it describes many techniques and many materials. But don't get caught on that. I want you to understand the main concept, and then the numbers, you can read it from the book, but that's the main concept. Your weather barrier, in this case, right, is on the chapter wall covering. And then of course you have your multiple materials that you can use to cover the outside, but also make it weather tight, right? That's the reason why they ask you about the size of the nail, how many inches you penetrate into the sheeting or directly to the stud, what size of nails, galvanized, not galvanized, and also the brick. Brick is a solid material, but moisture can also go through it, and if they do, they have to have a way to escape out. And that's the reason why bricks, they have whip holes, which is little tubies, on the lintels, which is above the windows, right, above the windows, or in the lower parts, to allow that moisture to escape out. And also another thing I want you to understand, for those that are new in the construction business, this is actually the house and their structure, this wood structure. The brick itself that you can see in these houses, they're not part of the structure. That's what they call brick veneers, right? They are just there to provide a look, which is in this case the brick look, right? Kind of like this. Let's see. but they are actually placed in front of the structural wall, right? But because they're very narrow, most of them are very narrow bricks, you know, then they have to be attached to the actual structure, which is this plywood, right? And how do you do that? By using straps. So the building code also talks about the straps that they need. You cannot see the straps on a wall when it's finished because the straps are embedded inside the mortar line. But you gotta have straps in different points. Okay, so I leave you that as a homework. How many or how often? So we can hold this wall straight up, right? And it doesn't buckle or collapse. It will do that because it's not a structure brick like it's described on the wall section when it talks about masonry walls. That's center brick walls. Those are big, massive bricks. These are not structure bricks. So I don't know if you can see. Those are what we call the whip holes, right? Little tubies. See? And this is actually a strap. Ooh, I'm lucky. You know, it's always good to come to construction site because you find a lot. That's a whip hole. Let me see. Let me put it very close. Whip hole. It's a little tubby. You see? Coming. Now you can see it closer. There are many. There's one right here. There's one right here. And in this mortar line, you have all the way across. So any moisture that passes this brick, which it will do, then it's stopped by your house wrap, which is on this house, right? So there is a drainage plane behind this, which is a house wrap, and then the moisture will come down and escape through the whip holes. Same thing. I don't know if you can see. This is a metal lintel that we use for bricks, right? So you can, I don't know, you can see. Let me see. It's a whip hole right there. It's another one right there. So every time you have a lintel at a brick, lintel made out of L-shaped iron, you have a soldier row in this case, which is a brick extending up. You gotta have whip holes, right? So this is a layer under the windows. When you have a layer, also you gotta have a whip hole. Okay, so whip holes are very important. You know, otherwise moisture will be built behind this brick or masonry wall. It will condensate. It will start creating mold inside your building, right? So look at these whip holes here. And in most applications you don't see it because they will cut it off flush with the brick. One time I passed through the school new building, and it was funny that some of our students were, because this is a tubby, they were putting some pieces of cardboard or cloth and blocking them. So that's not good, right? So now again, this is a strap that basically, as you can see, it has some holes, so it will be bent and nailed to the wall and placed on these mortar lines, right? So it will be placed there, so it will hold the integrity of this wall, right? So it's behind, right? It's behind. This is a strap that comes like this. So I found one, but then it's full, nailed, and then it's placed between the mortar lines. I'm gonna leave you that as homework how often you have to do, but you have to put many. In this case, this house has only a one story, and then the rest, you know, has a water table, and then it continues with the siding. So it has nice trim work on the outside. It's a $500,000 house. Quite expensive, but you know, now the market is going up for such a small house, but no driveway. You know, you can see the house has just a walkway all the way around. But that's what we're getting now here in the city as we get more congested and less space. I like to see this because construction sites, you know, see this black line is the first stage on a construction site, which is the erosion control, right? Even on that, you see there is erosion coming to the roads, but that's control erosion control, mandatory by the building code. Also, temporary line. I'm sorry, temporary electrical, and then your different types of suppliers like water. See these water, sewers. All of them, they need to be brought into before you start working, right? This house has a slab system. So on a slab system, it's just concrete. So I don't know, you can see, but the slab that's the footing. See, let me see. That's the footing and the slab, right? So inside there is all this good stuff that I told you about. Beside your concrete, you gotta have wire mesh, crushed stone, all of that. So this is your regular cleanup coming into the house. When it's a slab, all the underplumbing is going under the slab, right? Under the slab. So this is your cleanup coming to the street, and then you have all the other ones. So you can see there are some other houses that will be built, and then you gotta have on every construction site a way to dispose your waste. So you can see those green container and a portable bathroom. All right, you're supposed. Now these days, construction sites are actually also placing washing area, which it was mandatory, but some people don't do it for these moments that we're living, right?